Dear children, today we'll discuss about types of vectors. What do you mean by vector quantity? What do you mean by scalar quantity? How do we represent a vector quantity? All these things we have discussed in the previous class. Now we'll start types of vectors. And to represent a vector quantity, we need a directed line segment or a line with an arrow on it. The length of the line gives you the magnitude of the vector quantity, and the arrow that gives you the direction of the quantity. So let us start. First one is your equal vectors. Vector has both magnitude as well as direction. So two vectors are said to be equal if they have same magnitude and same direction. Let it be a vector. Now my question is, you draw another vector b which is equal to a vector. As magnitude is equal, then I have to draw a line of same length, and to make the direction equal, I have to put arrow towards right. It is your b vector. Now you can say that a vector and b vector are equal with each other. So now come to negative vector. What do you mean by negative vector? 5. The negative of 5 is minus 5. Means magnitude same, and here it is positive, it is your negative. In vector algebra, positive negative means that is direction opposite. You remember. Negative means direction opposite. Magnitude remains same. That means one vector is said to be negative of other if it has same magnitude and direction opposite to that of given vector. That means if it is a vector, if I will ask draw b vector which is negative to a vector, what will you do? You have to draw a line of same length as that of a vector. Its direction is towards right, then its direction will be towards left. So now you can write b vector is negative of a vector. That is b vector is equal to minus a vector. Now, repeating again, this negative sign indicates that in vector algebra, this negative sign indicates that the vector is opposite to the given vector. Means a and b are opposite to each other. So, now come to number 3, that is collinear vectors. You see, collinear, this word is a combination of two words. One is your co, the second one is your linear. Co means that is common, and linear that comes from the word line. Then how can we define collinear vectors? Vectors are said to be collinear if either they act along same line or along parallel lines. You see, it is a vector. What is the line of action of a vector? It is the line of action of a vector. If another vector b acts along this line, now you see A vector and B vector act along the same line. So you can say that A vector and B vector are collinear vectors. If another vector C acts along this line, now you see these two lines of action are parallel to each other. Now you can say that C vector is collinear to A vector. If I will put the direction of C vector is towards left, then what's about C vector? Whether that is collinear to A vector or not collinear to A vector. So you remember in the definition of collinear vector, nothing told about the direction, only told about their lines of action. If their lines of action are same, then it is collinear. Also, if their lines of action are parallel, then also they are called as collinear vectors. If C vector is directed towards left, that is opposite of A vector, then no matter, you see their lines of action are parallel, so C vector can be considered as collinear to A vector. That means in collinear vectors you will find either they have same directions or they have opposite directions. Depending upon the direction of the vectors, the collinear vectors are classified into two types. One is your parallel vectors. Number two, anti-parallel vectors. Let us discuss parallel vectors. Parallel vectors two vectors are said to be parallel if they act along same directions. If their directions are same, then they are called as parallel vectors. And you remember, same direction means angle between the two vectors is 0 degree. Can these two parallel vectors be equal with each other? Or when two parallel vectors can be equal with each other? So you know, parallel equal vectors, same direction and same magnitude. Parallel vector, same direction. Magnitude may or may not be same. So when two parallel vectors have the same magnitude, then the two vectors will be considered as equal with each other. Now come to anti-parallel vectors. Anti-parallel vectors, two vectors are said to be anti-parallel vectors if their directions are opposite to each other. It is A vector, it is B vector. If their directions are opposite to each other, then they are called as anti-parallel vectors. If directions are opposite, then angle between the two vectors is 180 degree. What's about their magnitude? Like parallel vectors, their magnitude may or may not be same, but direction if opposite, then they are called as anti-parallel vectors. When two anti-parallel vectors can be considered as negative of one another, that is when they have same magnitude. When two anti-parallel vectors have same magnitude, then they are considered as negative of one another. So now come to number 4, that is coplanar vectors. Similarly, co means common, planar means plane. Vectors having same plane or vectors acting along same plane are called as coplanar vectors. Let it be x-axis, it be y-axis, now it is xy plane. Any vector, any number of vectors in the xy plane can be considered as coplanar vectors, irrespective their magnitudes and directions. Now A, B, C are three vectors in the xy plane, so these three vectors are considered as coplanar vectors. Now come to number 5, co-initial vectors. Co-initial, co means common, initial means starting point, means vectors having common starting point are called as co-initial vectors. You see, it is a vector, its starting point is this one and end point is this one. So you see, it is B vector, starting point is this one, it is C vector and it is D vector. All the vectors have same starting point, that is O. Now you can say A, B, C and D are co-initial vectors, irrespective of their magnitudes, directions, of also plane. If they act along same plane, they also considered co-initial vectors. If they act along different planes, also they are called as co-initial vectors. Here, the necessary condition is that their starting point. If the starting point is same, then they are called as co-initial vectors. Now come to number 6, coterminous vectors. Co means common, terminus terminal point. Vectors are said to be coterminous vectors if they have same terminal point, irrespective of their magnitudes and directions. Here you see A vector, B vector and C vector, they all have same terminal point O, so A, B, C are called as coterminous vectors. Now come to number 7, localized vector or fixed vector. What is localized vector or fixed vector? You remember, localized vector means whose initial point is fixed. Initial point is fixed. It is A vector. If its initial point is fixed, then it is called as localized vector or fixed vector. Still it is not understood. Then to understand this localized vector, it is better to write point of application is fixed. Point of application is fixed. Means to explain this localized vector, let us take the example of force. In case of force, point of application, if you will change, the effect of the force will be changed. Let us take an example. It is a body. You see, if you apply force at here, then what happens? Then the body makes translational motion. Makes translational motion. When the body makes translational motion, the body has the center of mass. If the center of mass lies on the line of action of the applied force, then the body makes translational motion, linear motion. If you apply force at here, you see the body rotates. Body rotates. If you apply force at here, the body makes translational motion. If you apply force at here, the body makes rotational motion. If you apply force at here, then the effect of rotation, or it is difficult to rotate the body. That means if you change the point of application of the applied force, then the effect of the force is changed. And here the effect of the force depends upon the point of application. To get the same effect of the force, we have to fix the point of application of the force. That means force has the fixed point of application. That means force is considered as localized vector. If it is force, then you cannot shift it is the line of action of the force. You cannot shift the line of action of the force. If you shift, then the effect of the force is changed. So force is considered as localized vector or fixed vector. As the point of application or the initial point is fixed, then it is called as fixed vector. Now come to non-localized vector. Non-localized vector. That is free vector. That means initial point is not fixed. So you remember the vectors which can be described completely by its magnitude and direction. Point of application is not needed. Means you can shift the point of application. If you shift the point of application, then the effect will not be changed. Then it is called as non-localized vector or free vector. The example is your velocity, displacement. You can change if it is the velocity vector. If you change the point of application of the velocity, then the velocity vector it is understood. You can know what is the magnitude and what is the direction of the velocity, and the effect of the velocity will not be changed. That's why the velocity is considered as non-localized vector and or free vector. So it is all about your types of vectors. In the next class, we will discuss null vector, unit vector, vector multiplied by a scalar.